Hello and welcome to the Friday, October 17th, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Master's Degree Program in Information Security Engineering. Well, today's diary was really more sort of a little bit an internal thing, and that's a new DShield support Slack Workspace. We had Slack Workspaces for the last almost 10 years, I believe, that we started using Slack and has been quite successful. Sadly, Salesforce, which is the company behind Slack, for some reason that I haven't really been able to track down exactly how it happened, moved us to an enterprise account. Now, they're known to sometimes offer sort of trial pro accounts, but apparently they mixed it up with a SANS account, moved us to the enterprise account, and while it was nice to have the features, the bill was not quite as nice, and they weren't able to easily undo their mistake. So the only option we really had was to move to a new Slack Workspace. And that's what we're doing now. You should have already received an email with a link to the new Slack Workspace if you signed up for the original Slack Workspace. And there's also a link in today's diary. Also, all the other links to our Slack Workspace are hopefully updated. If not, let me know if something still points to the old Slack Workspace. The old workspace will be deleted on Monday, and then everything should be moved over to the new workspace. While we're talking a little bit about internal stuff, there was also an issue with a particular Pocket Cast application for Android with this podcast. They fixed it. It just required them refreshing the feed. And if you're a user of that application and you note that the feed isn't updated, you can actually request it from them. They were really amazing and quick in responding to have that working again. And any other podcast issues, so please let me know. I can't really test all the different feeds and applications people are using to listen to the podcast. And so if you run into any problems, please let me know. And then we have a bit more detail about the recently patched vulnerability in Cisco devices. This affected Cisco switches, and it was the SNMP vulnerability. Now, the vulnerability itself initially didn't really look that bad. It was well described as denial of service and remote code execution, but the remote code execution was only possible for an account with elevated privileges. However, even at the time when it was released, when the patch was released late in September, it already mentioned that this vulnerability is actually already being exploited. So now we got more details here from Trend Micro about how this vulnerability was exploited. And essentially, Trend Micro here explains that the attacker focused on older Cisco models, which did not do any address space layout randomization, which as a result made this vulnerability easier to exploit. It's exploitable on newer devices as well, but in order to bypass the randomization, it takes a few tries to actually make the exploit work. And I guess makes it a not reliable vulnerability to exploit. So they're focusing on the older devices. Once they gained access to various switches, they basically used that access in order to break down some of the isolations that you may have set up, like VLANs and the like, and make lateral movement easier. You typically then ended up with rootkits on your Linux devices. So that was sort of the end game here in this particular case, which then basically exposed you to a fixed username and password, sort of a backdoor access, and also a backdoor accessible via UDP. So they basically broke down your network protections by breaking into these Cisco switches and removing various security precautions that you may have configured, and then accessed individual endpoints they were interested in. Overall, a pretty sophisticated attack, but with this write-up from Trend Micro, you now have something to threat hunt for and make sure that you aren't already exploited. And as always, of course, make sure that you update your network equipment. And then we got an interesting blog post here by Paul Asadorian summarizing research done by researchers at Eclipsium about, not exactly backdoor, but something effectively a backdoor in Framework devices. Framework is a laptop manufacturer. They're famous for their very maintainable and modular laptops. And the BIOS in these, or the firmware in these laptops, comes with a firmware or boot shell. And this is not unusual. There's often sort of a little shell that executes before the system fully boots. You may have run into this if you had a corrupt disk or something like this, and the main operating system couldn't boot. But the problem with these boot shells is that, they have access to the complete system before it's completely booted. So if you're able to modify the system at this point, then you are able to, for example, disable some security features that the BIOS attempts to implement. And that's exactly what's happening here. There's a command, the command, that allows you to read and write memory. And with that, it's possible, for example, to override some security checks and even make them persistent across reboots. Pretty interesting research. Framework has addressed these vulnerabilities. I think for one or two models, they still have an update pending for this particular issue, but wouldn't be surprised if other manufacturers don't have the same particular issue. Well, and it's Friday again, and I have yet another SANS.edu student. Could you introduce yourself, please? Well, and it's Friday again, so it's time for another SANS.edu student, and their research paper with me today is Mark. Mark, could you introduce yourself, please?
Yeah, good morning, Dr. Ulrich, and it's Mark Stevens. I am a cybersecurity architect at Cisco, and I've recently completed my MS-ISE, which was a phenomenal experience.
Yeah, so great that you're all done, but in part to get done, you had to write a research paper. So what was the research paper about? Can you do a quick introduction on it?
Yeah, so I had a driver on why I needed to write this research. And it kind of started after one of my healthcare CISOs said to me, it doesn't really matter what we are doing. We believe that we're breached. We believe that the adversaries are already inside of the network. And so after a little bit of thought, I was like, okay, if somebody's already on the inside of the network, what's the best way to detect them? And so I focused on active defense and adversarial engagement. So the ability to be able to identify that the malicious attackers are inside of our environments and to get them to reveal themselves by making mistakes, by encouraging them to make mistakes.
So just to clarify, active defense here means more something like deception. It doesn't mean hacking back.
So it absolutely means deception and studying. So I did use the MITRE Engage framework. So everyone's familiar with MITRE attack framework, where we look at TTPs of different campaigns and techniques and tactics that adversaries are using. Well, there is I'd say, little known or little used framework called MITRE Engaged. And MITRE Engage actually enables us to actually build detections, deceptions, and also ways that we can study adversaries in our environment. So it's a kind of a progression of different ways that we can learn and engage with the adversary. Hacking back should be left to somebody with a federal government type of activity. So not advised to hack back.
Yeah. So, what kind of actors did you apply that to? Was it sort of more your average, run-of-the-mill exploit, or were you really more looking for more advanced attacks here?
Yeah. So actually, I purposely did not choose an extremely advanced, malware injection or some type of attack. But I looked at the principles and the concept of MITRE attack framework, where an attacker progresses through the stages, once they have initial access, then the next phase typically is discovery. So if I focused on that, so my research started from the concept of the attacker's already on the inside of my network. How do I enable, or how do I identify when an adversary starts to try to discover more or better, richer targets inside of my environment? So I focused on a lot of scanning, the ability for them to discover infrastructure in the network, the ability for an adversary to actually start active scanning and looking for systems. And then, of course, once the system's compromised or has been accessed, then how do they, when they start looking for the crown jewels, the files, the things that they may want to either encrypt or steal in the environment. So I didn't progress forward into some type of reverse malware reverse engineering concept. I wanted to focus on the reality of the adversary inside my network, and now they need to expand inside of that environment. And of course, if you look at many of the active campaigns through MITRE attack, each one will say, like fintech, once they've had initial access, their next phase is discovery. What can they find inside of an environment to be actually steal, destroy, or encrypt?
Yeah, can you walk us through sort of a little example, like how would they find a particular document, or and sort of how that informs your detection here?
Yeah, so the way that I did it, it has to be, because it's a research project, it has to be some type of controlled environment. So I did build an environment that I knew that I leveraged deception technologies. I just deployed honey tokens on a Linux platform. I wrote and deployed a honey pot in my environment, that when the honeypot was actually accessed, then it would actually send alerts into a professional system, Cisco XDR. I used that because that's what I had available. And then finally, comparing active scanning of an environment to planting networks. So, kind of the dark nets inside of our environment where we know there should be no activity. Once we see some type of active scanning into that environment, then at that point, I want to be able to detect and respond to that. So honey token, honey pots, and then dark nets or honey nets, if you want to use a honey phrase, with inside of those. And so I built each of the research test experiments around that. The first one was simply, assume an adversary is in your environment. They're not going to have Kali Linux, right? They're not going to have some attack tool already. Maybe they upload it, but it's most likely that they're going to be find a foothold on some existing system. So I chose in my research, a simple Windows, poorly secured Windows platform where we assume that they already had access. So what tools from Windows are there at that point for them to be able to launch? In this particular system, I allowed them to install Nmap. And once they have Nmap on there, then at that point they could do active scanning of networks, right? So I placed target honeypots in a network with a number of other servers. When that Nmap session scanned and made a connection to that honeypot, at that point, it's a high fidelity alert. So, and that's one of the things I think it's worth noting, that in a active defense posture, it is often a goal to have a high fidelity detection that we can close down the time, the detection and the response time. So actually enable us to know that there's somebody in the environment that we want to collect, or we want to respond to. That's actually, so going back to MITRE Engage, interestingly enough, there are scenarios where you may wish to actually study the adversary in your environment. And that studying means allowing the adversary to proceed through their attack so that you can see what commands did they use, what are they actually looking for. Now, again, I would suggest that only being for the most sophisticated of organizations to allow a potential adversary into your environment and knowingly and allow them to move. But there are areas where you can now build sidecar networks or environments that that you know that the adversary can attack. Call it a network that you don't mind being compromised with inside of there. So once you have that environment, so let's back that up. So you could either put some simple detections in the environment that as soon as something connects to it, that is a high fidelity attack, detection, or you could build some environments so that you allow the adversary to proceed through and get further into a false environment, but we make it look as real as possible. We make it look as attractive as possible for a real target. So first is services. Then it would be the honey token concept. And the honey token concept is, maybe it's false files that are full of passwords, files that are full of crypto looking keys, files that are some type of personal identifiable information that an attacker may be interested in to achieve or retrieve. Right. So that's another, that honey token has to be attractive. So we're assuming that the adversary is on the system. And then once the adversary is on the system, they're then at that point going to search for it. If you look at the average Linux platform, right, the default configuration, you can run find commands on the Linux system, and it really doesn't generate any logging of any interest. So in a honey token environment, because we know these are the files that we want them to find, at that point, I wrote a simple Python script to look for a file access. And then once the file was accessed, to be able to capture the user credentials, to the file type, the timestamp, and then to send that via syslog to a target. And once it's sent to a target, at that point, you can build detections from that. The goal was to give us more telemetry to be able to take to feed into a detection. Once we have a detection, then we can respond accordingly.
The way you described it was really sort of more a little bit that threat hunting scenario basis. You assume compromise, now you try to find the attacker. Do you think that's sort of part of threat hunting, or could also be sort of part of intrusion detection, basically detecting intrusion before it sort of happens?
Well, I would recommend not putting honeypots on the internet side. So to place honeypots or any type of detection on the inside of the network, I'm focusing on, in my research, I focused on the concept of the adversary is already inside of the network. There's many pundits out there will say there's two types of organizations, right? The ones that know that they're compromised and the ones that are compromised, right? So it's a concept of, if we place ourselves in a state of paranoia that the adversaries are in our environment, this is a healthy step to not overwhelm our SOC with extra information. This is a targeted deception and active defense system inside of our environment that we know that if anything connects to it, then at that point it is something we want to investigate. Because and some of it may be, I put a honey token on an executive's machine. It's hidden. It's in a hidden directory. The executive really should never be able to see it. But suddenly, if a process scans that system and accesses that file, that's a good indication that something unusual is going on with that system. So any way that we can create a new detection or an early warning detection inside our environment, that's what we're really focusing on. Arguably, you could say, well, this threat intelligence. That's where once we understand. So importantly, active defense is not static. Active defense needs to move with the campaigns that are being used or the vulnerabilities that are actually in our environments from by the attackers. So if we deploy static honeypots, that's really not going to be a huge amount of value. But if we can deploy dynamic honeypots or dynamic files or services via containers, think about Log4j when, and I realize it's still actively scanned and it's still actively exploited in our environments out there. But as that was first deployed, if we had a container that was a honeypot that could kind of simulate the services and the vulnerabilities for Log4j, and something connected to it. Well, at that point, again, high fidelity detection, and gives us a great opportunity to actually study what are these adversaries actually after in the environment on that side. So arguably, it is absolutely about active defense and detection of something that may be inside our environment, but it also enables us to look at active threats that are ongoing and be able to continuously iterate our active defense environments. And the more sophisticated organizations can actually take that information that they learn and feed it back into our defenses. So changing our SNOR signatures, our WAF signatures, or maybe even how something may be gotten into an environment. So absolutely, it is not only something we deployed to ring an alarm bell, but something we deployed to make the blue team better.
Yeah, thanks for that summary, Mark. And link to the paper will be in the show notes. And hope many people will enjoy it and, well, maybe deploy some of those ideas in their network.
Thank you. Thanks, Dr. Roback.
And that's it for today. So thanks for listening, and talk to you again on Monday.